Welcome back, everybody. Today's topic, 1.3.1, how can I rewrite it? Rewriting expressions with exponents. The distance learning target will be by the end of this lesson, I will be able to rewrite expressions with exponents in equivalent forms, as evidenced by identifying shortcuts to formalize the laws of exponents. So that's what we're going to be doing. For some of you, it might seem a little bit more like review, but this is not too bad. So hang tight. Make sure you guys have the notes ready. Again, you guys can download the notes, print them out, or you just use watch the Edpuzzle lesson on your phone and then take notes on your computer as well. First question right there, an expression like b raised to the a. B is called the base, and it is called the x, and a is called the exponent. All right, so we read this b raised to the a, b raised to the a. All right. And again, the B stands for the base. And then in this case, the A, which is a little right there, usually it's a number, sometimes it can be a variable, is a little number on top right there. An exponent is a shorthand notation, all right, for repeated multiplication. For example, the expression n to the fourth is equivalent to n times n times n times n. So the little number on top just means pretty much how many times I have to multiply the same number by itself. So we want to expand each of the expressions below. For example, to expand x cubed, you would rewrite x times x times x. So the first one right here, y raised to the 7, we would have a total of 7 y's that are multiplying. 3, 7, all right. And then the next one, part B, so here, 5 times 2, 5 times, remember parentheses and a number outside means multiplication, times 2 raised to the third power. So we just need to expand this 5. That one is outside the parentheses, so we don't have to expand it. So this would be 2m times 2m times 2m. The next problem we have C is x to the third power and then raised to the second. So again, the parentheses tells me that this whole thing inside of it has to be multiplied twice. So we would just rewrite this as x to the third times x to the third. And then lastly on D, 4 times x to the fifth power. Well, actually here, we still want to continue. So this would be equal to x times x times x, and then again, x times x times x. Now let's look at D. So again, the 4 is by itself. It doesn't involve an exponent. So this is 4 times x to the fifth times y to the second power. So this is 4 times, and then we're going to have a total of 5 x's. So 1, 2, 3, 4, 5, and a total of 2 y's. All right, let's look at the next problem right there, 165. Ms. Wang has just explained to her class how to write a simpler expression by using the number 1. So she wrote the expression and right on the board. So you want to either copy this onto your notes or you can always just see it right here. So we have x to the second power times y to the eighth over x times y to the second power, right? So explain each step. So let's call this one the first step. And then on the next one, the next equal sign would be the second step. The next equal sign would be the third step. And then the last step would be number 4. So on the first step, if you notice what she does is that she expands, pretty much matches the ones. So there's 1 at the bottom here. So we have x to the first on top. And then since we had 2 on top, then you see there's still 2 on top, right? If we were to expand that. And then out of the y's, she got a total of 2 out of it, right? So if you notice, she's making sure that she has 2 from the top as well. Again, the reason is because if we divide any number by itself, we always get a 1, right? So that we're essentially, the variables represent a number. So if we're dividing a variable by itself, this would always be equal to 1. Same thing if you have a different exponent, like y to the 5th power over y to the 5th power is still equal to 1. So that's pretty much what she's doing there. So on the first step, she identifies the big ones. We're going to call them the big ones to simplify. On the second step, she divides those out, and all is left over is just the ones right there. So on step 2, she just simplifies the ones. The big ones, let's call them the big ones. All right. And then on the third step, let's do it over here. On the third step, she just, again, compacts everything, right? So she writes everything together, And then by the fourth step, she just puts x times y raised to the 6, right? So the fourth step, right? If you divide anything by 1, it's always the same number back. So she just simplified one more time. So explain why x times y to the 6 is simpler than Miss Wang's starting expression. So why is it simpler than x squared times y to the 8th over x times y to the 2nd power? Why is this simpler? X times y to the 6th. So if you notice, pretty much one of the main reasons why it's simpler is because we only have to write x and y once, right? So the bases only appear once if we compare it to the other one, which was twice, right? One on top, one at the bottom. So it's always a lot simpler to make sure we just have one variable for dividing. And then part C right there, rewrite each of the expressions. Below, start by expanding the expressions like Miss Wang did, and then show how you use the giant one, or the big one, to write an equivalent expression in simpler form. So here, we have one on top, one at the bottom, so that's our giant one. Just calling it the big one, we can call it the giant one. So that's going to leave us with just x times x, and that's going to be x squared. On this one, if we pull the 2 out of the top one, we're going to have x squared over x squared as well. And then we have 3 left over, so times x over 3 over 1 times y. So again, there's a giant 1 right here. That divides out, and you're left with x to the 3rd times y. Now here, if you notice, we have w's on top. We have 2 on top and 2 at the bottom. So if we were to expand these, if you notice, we would have a total of 8. So we can rewrite it like this first. And then we can just get the giant 1 out of it. So that would be w to the 2nd power over w to the 2nd power times w to the 6th. That's our giant 1 right there. Divides out, and we're just left with w to the 6th. And then on number 4, if you notice, we have 16 divided by 8. So we can divide that for sure, times z squared over z squared times z to the 1st over 1. So 16 divided by 8, that's 2. This is our giant 1 right here. And then times z to the 1st. So our answer is just 2 times z to the 1st power. All right, and then the giant one can also be used to simplify scientific notation. Start by expanding the expression like Ms. Wang did, and then show each how you use the giant one to write an equivalent expression in simpler form. So be sure your simplified expression is in scientific notation. All right, so we're going to do 12 times 10 raised to the ninth over 4 times 10 to the third. So we can rewrite this again. We know it's 12 divided by 4, and then times 10 to the third over 10 to the third, and then times 10 to the 6. Oops. So this is our giant one right there. And then 12 divided by 4, that's 3, and then times 10 to the 6, which was this thing that was left over, right? The number with the exponent. And then on the next one, if you notice, we have an exponent outside, so we have to do that first. So this is going to be 8 times 10 to the third times 8 times 10 to the third over 4 times 10 to the first power. So here we're going to multiply the 8 times 8 first, and that's going to give us 64 over 4, and then times 10 to the 6 divided by 10 to the first. 64 divided by 4 is 16. 10 to the 6 divided by 10 is 10 to the 5th.